Okay, hello. My name is Gordon Stove. I'm the CEO of Adrock. We're a technology company based in Scotland. And I'm here to tell you about how we're helping de-risk the exploration for suitable geothermal drill targets in the subsurface using our innovative technologies. So the technology we've developed is a radio wave technology. So we send radio waves deep into the ground. We figured out how to get over the problem of attenuation and energy loss by stacking tens of thousands of radio wave returns at the same time. We send a range of frequencies into the ground, ranging from 1 megahertz up to 70 megahertz, and that gets us down into a sort of 1,000 meters plus of penetration through the ground. So the technology was initially used for the oil and gas industry, and we've adapted it to geothermal exploration. We have been using it for enhanced oil recovery applications, monitoring steam injection into the ground. And from the calculations of figuring out how to measure temperature in the ground, we have created a geothermal proxy algorithm set for measuring temperatures in the ground. And we've been down to 3,000 meters in the Perth Basin in Australia, which I'll talk about as a case study. So fully processing these results can be obtained very quickly within a matter of weeks rather than months or even years. So therefore, our technique is very cost saving, it's very quick, and it's environmentally friendly because we use non-destructive radio waves from the ground surface without drilling through the ground to measure the temperature in the ground. So I'll talk about some case studies in Cornwall in the UK, California. We've done over 100 projects in California so far, and Western Australia and New Zealand. We've done some projects there as well. So the technology itself, as I mentioned, we use frequencies of 1 megahertz to 70 megahertz. We can collect 4 virtual borehole drill holes per day. It takes about 2 hours to collect data at one site. And we can collect to depths of over 1,000 meters of depth. And it's a very quick, portable technique. I mean, the system is here. It's one transmitter, one receiver. We've got one radar control unit, receiver control units, and one transmitter control unit. And we collect everything in the time domain and frequency domain. So every single transmission is time stamped, and every return that comes back to the receiver is time stamped as well. So we know the depth in which we are collecting data. So we borrowed some principles from traditional ground penetrating radar, as well as seismic reflection technology. So the radio waves are basically reflected and refracted back from the subsurface, and the rock property we measure is the dielectric, which is based on conductivity. So a mixture of dielectrics and conductivity is the main rock property we measure. When we encounter heat, we tend to have a higher dielectric. There's a higher conductivity response due to the heat. And it's the same with water. Water gets a higher dielectric response as well. So we've proven the depth of penetration. I mean, this was traditionally an issue or an obstacle for classical geophysicists. We had to physically take our equipment out into the field and prove up the penetration depth. One particular test we did with a company called Tech Resources in Canada. We went to one of their mines underground, and we went 300 meters underground, and we pointed the antennas vertically upwards from inside the mine. And this is a mine called Ponderay in America. And we sent the radio waves up through the ground, through the solid rock material, and we hit a water body at the top here, which is a river channel that we hit. And we got signals through the rock, through the water, and out the other side. And we knew this because of the dielectric responses that we were getting from the subsurface. So we had low dielectrics until we hit the water, and the water layer here is a high dielectric, went off the scale into 80 value of 80 here, with the rocks being of sort of constant dielectrics from 4 to 5 to 6 type value. So we published this paper. This is a presentation we made at the Society of Exploration Geophysicists in Denver in 2014, and a paper can be downloaded and read about that experiment. So this demonstrates the fact that radio waves can penetrate deep into the ground. So there's no issue about skin depth or anything like that, which we overcame. So moving on to some case studies. So we, as I mentioned, we developed the temperature proxy calculations using Stefan Boltzmann's law, and we derived temperature from these equations here. And we did this for the oil and gas industry. So we did a lot of work for a company called Chevron in California, for example, and ERA as well. We worked with them, and we produced this temperature proxy by measuring the steam injection into the ground. So we went to areas that were cold, where there was no steam injection, and then we went to areas which were classified as hot, where there's steam injection. So this example here shows a single chest steam injection that was into the ground. There was a big spike here, which was corroborated by this is the calculated temperature downhole, and the blue is our dielectric temperature, which we were measuring from the Stefan Boltzmann's law using our energy returns. New Zealand, we went to a site, we were allowed to go onto the site owned by and run by Contact Energy in the Wairakea site. And we did some tests there. We just some calibrated tests along known areas where the temperature was measured, and then we went to areas which the temperature wasn't measured, and it was an area that they were exploring for heat. But from the controlled tests, and these are examples from the controlled tests, we had some good corroboration of the temperature changes in the subsurface from the geothermal sources. So Contact Energy kindly allowed us onto their land, and we surveyed their sites. And in some cases, there was multiple sources of heat in the subsurface, all stacked up amongst each other, which we had to differentiate as well. Sorry. Another test was in the Perth Basin in Western Australia. Now, this was an oil and gas site. So there was a company called Green Rock Energy that allowed us to go onto their site. It was run by Origin Energy, the oil and gas company. And we were measuring against seismic and also downhole tool measurements. So the temperature measurements that we had here versus the drilled location, I mean, there was a slight offset in the temperature. However, what was interesting was that we managed to track the oil and gas and the shale layers because of the conductivity through a repeated line of scans over a cross section through the ground, which was good correlation against the seismic as well. So we had good correlation with the geology and also the drill holes. So it was an excellent test, and this went down sort of 3,500 meters through the ground. So it was a deep measurement through the subsurface. So we're a European-based company, so there's lots of interest in Europe just now for geothermal energy, and we can provide huge advantages over current technologies for finding sources of heat in the ground. As I mentioned, we do this all without drilling a hole through the ground. So the biggest capital expenditure and the biggest OPEX for a geothermal search is the drill hole. So we remove that cost. So we're at technology readiness level 8, and we're just about at level 9. We're not quite at a commercial operation state yet because we haven't had many commercial projects. All the projects we mentioned, we self-funded ourselves. We put our own money where our mouth is to prove the doubters wrong, as it were. There's lots of skeptics out there. So we funded all that. We paid for everything and demonstrated the technology ourselves. So as I mentioned, it's a low impact. There's very low impact on the environment. So it's very environmentally friendly technique. There's no noise pollution. There's no damage to the ground. We don't drill through the ground, and we reduce that cost of drilling through the ground. So as a quick and safe and environmentally friendly method for exploring for heat in the ground, this is an ideal technique for doing that. So we're making a call out through this conference for people that are interested in trying out our technology. There's lots of sites, as I mentioned, onshore Europe, onshore USA, North America, that would be ideal candidates for trying out our technology. So as I mentioned, we have a few thank yous to our chief scientific officer, Kees van den Doel, technical officer Michael Robinson, and our founding inventor of the technology, Colin Stove. And the company is Contact Energy, Green Rock Energy, Origin Energy, California, the Chevron as well. And these are some references as well, which we've got. We've got some papers published on this work already. So thank you very much for your time, and I hope you enjoyed this presentation.